Okay, so in this video we are going to be adding and subtracting algebraic fractions. This one in particular is using the kiss and smile method. And so for all of these we are being asked to express the following as a single fraction in its simplest form. With these questions you'll always see these little bits on the side here. And essentially they are just stating that A and B can never be 0 because you can't divide something by 0. And same idea over here, Y and Z can never be 0. And you'll see it with all my other questions, and I've got 6 to go through total. And the reason why in these ones it's a little different, here it's saying x can never be 1 because 1 take away 1 would give me 0 there. And x can never be -3 because -3 add 3 would give me 0. So they're just adding a little bit more context to the question. You don't have to worry about them. So let's just get started. So algebraic fractions is going to work pretty much the exact same way as our numerical ones. The idea is we want to get our denominators to become the same. So I multiply across the diagonals and I multiply the bottoms together. And I'm just going to neaten it up a little bit. So I've now got 5b over ab plus 2a. Now I can write BA, but I'm just going to swap it around to AB, exact same idea. And now my denominators are the same, I just add the tops together. And I can't collect any like terms there, so that's my final answer. So same idea over here, just extending that line. So I'm doing x times z. 3 times y, then multiply my bottoms together. And so I'm just going to neaten it up quickly. So I've now got xz over yz, take away 3y over, and again I'm just going to swap that around so it's the same. And then just take away the tops, and once again I can't collect any like terms, so I just leave it like so. Okay, so these next two questions here, this is where the kiss and smile method does come into a bit of difficulty. I'm going to start off with just process it the same way I have been doing. So 2 times x squared, 3 times x, and multiplying the bottoms. So I've now got 2x squared over x times x squared is going to give me x cubed. And then I take away the tops. Okay, so at this point here, it is very tempting to just move on to the next question. You've managed to get on a single fraction, but the thing you need to look out for is a potential common factor that's going to occur on the top and the bottom. So on the top, all my little parts all have an x, and on the bottom I also have an x. So that means I can do a bit of simplification, I can do a bit of factorising, a little bit of division. And so that's what I'm going to do. I'm going to factorise the top. So my highest common factor on the top there is x, and then I'm going to have 2x minus 3 inside the bracket. Because I have an x here, I just want 1x on its own for me to cancel out. And so left I have is that x squared. And then I cancel out those x's. So my final answer is going to be 2x minus 3 all over x squared. It's the same idea over here. So again, multiply across the diagonal. Multiply my bottoms. Okay, so on the top there, generally like having numbers at the front, so I'm going to have 6tr. And on the bottom, 4 times the 6 is going to give me 24. Then I've got r squared times r, which is going to give me r cubed. And then next one, I've got 5 times 4, which is going to give me 20. Then I've got that r squared all over 6 times the 4 is going to give me 24r cubed. So again, I can put it all onto one fraction. And now this time, I've actually got quite a few factors that I can get rid of, because not only do we have an r in all my parts, but also if we look at the numbers, I've got a 6, a 20, and a 24. They are all even, so I can definitely divide them all by 2. And again, I'm going to follow the same idea as I did in the previous one. I'm going to find my highest common factor. So my highest common factor for the top part is going to be 2r. And inside the bracket is going to be 3t minus 10r. And so I want a 2r to cancel out. And 2 times 12 will give me that 24. And then I've got left is that r squared to give me that r cubed. Cancel out the 2 r's. And that's now going to be 3t minus 10r all over 12r squared. And I've got no more matching bits for me to potentially cancel out. So that's that question done. So this is the difficulty with the kiss and smile method. It's keeping an eye out for when we can do this factorization in order to do a bit more simplification. Okay, so next one then. So I've got 2 over x minus 1 and then plus 3 over x plus 3. First thing you should always do when it's a group is just put brackets around it. So they are little sections. Okay, so same idea. Setting up my bracket. And so I'm going to do 2 times the x plus 3, 3 times the x minus 1, and then multiply my bottoms together. So I've got x plus 3 and x minus 1. Okay, so what I'm actually going to do is I prefer putting it all onto one bracket first. So I'm not going to do any expansion, going to put it all onto one bracket. So I've got 2x plus 3 plus 3x minus 1. That's all going to go over that x minus 1, x plus 3. Now at this point here, we are going to expand the top part because this can become a bit more simplified, but I don't need to worry about the bottom part. That is as simplified as possible. There's nothing that's going to cancel out. So, or there's no collecting like terms, for instance, that's going to happen. So you just leave the bottom part alone. So expanding the top part of my fraction, it's going to give me 2x plus 6 plus 3x minus 3 all over that x minus 1, x plus 3. And then I'm going to collect my like terms together. So 2x plus the 3x is going to give me 5x, 6 take away 3, it's going to be plus 3. And then my bottom, again, just stays the same. And that's it. Okay, so let's take a look at this next one. So again, I'm going to put those brackets in. So I've got 5 over n plus 4, take away 2 over n minus 1. And so the reason why we expand the brackets after I put it all onto one fraction is because one common mistake that happens is that if you expand beforehand, when it is a subtraction here, a lot of people remember to subtract the first part of like the expanding, but then forget to subtract the second part. So that's why I prefer just getting it all onto one fraction first. And so I've now got 5n minus 1 take away 2n plus 4 all over n plus 4 n minus 1. Expanding the top part, I've now got 5n minus 5 take away 2n take away 8 all over n plus 4 n minus 1. And then just neating it up, I'm going to be left with 3n take away 13 all over n plus 4 and n minus 1. And before we finish, there's actually one more that I do want to do that I forgot to write up. So I'll just do one more. So our last one is going to be x plus 3 all over 5 plus x minus 1 all over 2. Okay, so again, same idea, you want to put brackets around it. Then writing out my fraction. And I've just slightly changed how I've organised it. The reason why is because when I do that x plus 3 times the 2, essentially what I've got is that 2 bracket x plus 3. And same idea here. So this time I've just sort of stuck it at the front just because it resembles more our expanding brackets that way. And then multiplying the bottoms. And so then I've got, why did I write times 10 on the bottom there? That's going to be times 5. And then putting it all onto one fraction, same as before. Oh, I went to expand it. There we go. Ooh, stop it. There we go. And then I can expand my brackets. And collect my like terms. And that is adding and subtracting algebraic fractions. Let me know if there are any issues, and good luck.